our word equation is aluminum bromide and chlorine gas react to form aluminum chloride and bromine gas. So we have a single replacement reaction here, and we have to write out the skeleton equation, and then we have to balance that skeleton equation and come up with the molar ratio that we can use again in our stoichiometry at the end. So let's go ahead. Aluminum bromide, there is no Roman numeral here, so we know that it is a type 1. So we have to get the charges for both aluminum and bromine. Okay, so we're going to come ahead and we're going to look at aluminum. And the easiest way to do that is to go to our packet. Again, use your packet. So once we get to our packet, there's two ways to do this. You can go over here. We know that we have listed on column. This is column 3A. So we know that it has 3 valence electrons. Or we can go down to page 13 in our packet. Once we get there, there is page 13 right here. And we can find aluminum. This is our common monoatomic ion sheet. So everyone that's listed in white here is a type 1. The green, if the first element, and this is all about the first element. So here's, if the green, they're monoatomic too, but if they're both green, then that means it's type 3. So we're going to go ahead with the aluminum. It is a +3 charge. And then we have the bromine. The bromine is over here and is a -1 charge. So we go back to this. We have a +3, and in the bromine we have a -1. So how do we get these together? Remember, they don't cancel each other out. So we're gonna crisscross. So this 1 becomes down here. Okay, so I could put a 1 there, and I know that the bromine is going to be a 3. So when I come down here and write this out, I'm going to write down the symbol for aluminum was Al, and I only need 1 of them, so we're not going to write that down, but we're going to make that a lowercase l. Then we're going to take our Br and use a subscript and change it to a 3. Go back up. We're going to add that to chlorine gas. So chlorine is just going to be Cl. Okay, now we're going to, that's going to react, which means that it's going to yield aluminum chloride. So aluminum again, this aluminum over here is still a +3. So we're going to put a +3 there. And then our chlorine, we have to figure out what that is. Okay, so our chlorine, how are we going to do that? Again, we're going to go back to our packet, find chlorine. Chlorine is in the same column as bromine, so it's a -1. So we're going to come over to the chlorine, and we're going to put a -1. So again, they don't match, so we're going to crisscross. So I'm going to put a 1 here, and I'm going to put a 3 right there. So when we go ahead and write this out, we're going to do Al. I only need 1 of them. Then we're going to put Cl, and then we're going to put a subscript of 3. And then we're going to add, or another byproduct is going to be bromine gas. So we're going to bromine. Now again, we could say, oh, we're done. We're not done though, because we have to ask ourselves, as always, whenever we have an element by itself, is it diatomic? Okay, so remember, do you remember what the diatomics were? There's 7 diatomic elements. So when they are by themselves, we have to make sure that there's 2 of them, and we use the subscript of a 2 for that. So let's go back to our packet, and let's look at the elements that are diatomic. We'll go to the periodic table, and again, you can use your packet, your hard packet, or you can use the one digital here. Get used to using all of them. So we look at our 7. They make a 7 on the periodic table, if you remember that. Okay, but 6 elements make a 7, then there's an extra one. So where are they at? They're right over here. So it's nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Those are the 6 plus hydrogen. So chlorine and bromine both are diatomic. So what does that mean with our skeleton equation? Well, what it means is right here after each one, we have to put a subscript in of 2, which means that they are diatomic. Okay, there we go. And now one thing that I can write out here, since I have a little bit of room, I know that I'm looking for my molar ratio. Okay, so we have to balance it. So how do we balance this problem? And again, I like to go ahead and put in a couple of stops right here. Okay, doesn't matter how I'm going to do, so we're going to tab over to the center here. I have no polyatomic ion, so I don't have to keep those together. So I have the single elements. So we have aluminum, okay, and I should have done this. Okay, so I have aluminum, and then I have bromine, so we're going to put Br there. And then we're going to go over to this again, and we have chlorine. Now, do I have the same thing on each side? Yep, aluminum, bromine, and chlorine. So now what we have to do is figure out how many that we have on each side. We look at the aluminum, and I'm going to say here, I only have one aluminum. So we're going to put a 1 right there on this side. I go to this side, I only have one aluminum. I go to this side with the bromine. I look here, I have 3 bromines. So I'm going to put a 3 up here. And then over on this side, I look at the bromines, I have 2. Ooh, interesting. I go to the chlorine. On this side, I have 2 chlorines. Oops. On this side, I have 3. So my aluminum is good, so I have to change this. Now, one's always going to be in multiples of 3. The other one's going to be in multiples of 2. So we got to figure out what number that each one can go into. Okay, and the easiest way most of the time is just go ahead and multiply these 2 numbers together, which gives us 6. And then we just got to see, is that the the lowest number that each one can go into? In this case, it is. So we have to make each one of these 6. So how do I make this 3 a 6? I have to go ahead and put a 2 right there. If I put a 2 right there, that means I'm going to end up having 2 aluminum, but I'm going to have 6 bromine. So I'm going to go over to the other side, and I got to make sure that I have 6 bromine on this side. So what times 2 equals 6? And we're going to put a 3 right there. And that means that we're going to have a 3 right there. And now I got to change the aluminum. So let me change the aluminum. I'm going to put a 2 right there in front of that aluminum, which makes this a 2. But it also makes my chlorine, 2 times 3 is 6. And so I have to change this over here on this side to 6. I have 2, so what times 2 equals 6? And I'm going to put a 3 right there, which is going to change this to a 6. And now we're go ahead and we're done. We're balanced. So let's double check it. I have 2 aluminum on this side. I have 2 aluminum on this side. I have 6 bromine. 3 times 2 is 6. On that side, 3 times 2 is 6. On this side, chlorine, I have 3 times 2 chlorines is 6. And I have 2 times 3 chlorines is 6 on this side. So we have our molar ratio. So again, our molar ratio is the coefficients that we have at the end. And remember, we can never change the subscripts, because if we change the subscripts, it's not the compound that we have. So let's go back to the molar ratio. So I have 2 to 3 to 2, oops, to 2 to 3. That is our molar ratio. So we have 2, 3, 2, 3. Again, I like to highlight it, take a look at it, and say, okay, can I reduce it? In this case, we cannot reduce it, so that's our answer. Let's go ahead and make it bold, and let's highlight it with a color. And there we go. There's our answer. 2323 is our molar ratio, and that is a balanced chemical equation for practice sheet number 3, problem number 2. As always, go Mohawks.